Hey, y'all, let's cover guided notes 1.2. So using the product rule, write each of the following products with a single base. All right, so the t is the base, the 5 is the exponent. Same thing for here, the t is the base, the 3 is the exponent. The product rule is when you're multiplying the same bases, you can add the exponents. So this becomes t to the 5 plus 3, which is t to the 8. All right, now we've got -3 to the 5 times -3 to the, is that 0? Is it 1? What is that? It's 1, because if it was 0, this would just be 1. So -3, that can be -3 to the 5 plus 1, which is -3 to the, that's parentheses, to the 6, which is what? You can plug that into your calculator, or I can just go -3 times -3 is 9, times -3 is -27. I don't know if I can go that high. So two of them would be 9, 9, and then 9. -3 times -3 is a 9. So 9 times 9 is 81. Times 9 is, oh God, that's 729. The main thing is that you get this part right here, that if the bases are the same, you can add the exponents. That's what I want you to get from this. Here, the bases are all the same, so we're just going to add the exponents. So x to the 2 plus 5 plus 3 is x to the 10th. Using the quotient rule. So quotient rule, same bases. When you move one from the denominator to the numerator, the exponent changes sign. If you move a term from the numerator to the denominator, the exponent sign changes from positive to negative or negative to positive. In this case, I always go to where the largest positive exponent is, because I want you to provide your exponent positively, not negative. So because the 14 is already positive, we're going to bring this 9 up here. So I'm going to subtract 9 from both. And that gives me -2 to the 14 minus 9, which is 10, 11, 12, 13, 5. And then this is -2, 9 minus 9 is 0. Anything to the 0 power is 1, period. So now we have -2 to the 5th over 1. So I'm just not going to put anything for the denominator. All right, let's go ahead and calculate this real quick. -2 times -2 is 4. 16 times -2 is -32. All right, t to the 23rd over t to the 15. We're going to subtract 15 because the 23 is positive. And we get t to the what? 23 minus 15. That would be 8. Yep. Z square root of 2 to the 5th over z square root of 2. So keep in mind, this is a 1. All right. So I'm going to subtract 1 from both. And I get z square root of 2 to the 4th. That gives us z to the 4th. And then square root of 2 to the 4th would be, square root of 2. That's a 2 to the 4th. Square root of 2 squared, this can be broken down into square root of 2 squared times square root of 2 squared, which would be 2 times 2, which is 4. So where was I on this? Right here. So this is going to be a 4. There we go. All right, using the power rule, write each of the following products with a base. When you have an exponent raised to an exponent, so we've got x squared raised to the 7th power, you multiply your exponents. So that becomes x to the 14th. 2t to the 5th, and all of that to the 3rd. Well, this is taking 2t to the 5th. We start with the inner one first. So that becomes 2 to the 5th, t to the 5th. And then we want to cube it. So that becomes 2 to the 15th, because remember, you multiply your exponents, t to the 15th. I'm not going to calculate this out. You can plug in 2 to the 15th to your calculator. Doesn't sound like fun to me right now. So I'm going to leave that as my answer. I would expect you to at least write down their number, because you can use your calculator, and then t to the 15th. The main thing is that you understand how the exponents work. -3 to the 5th to the 11th. So this is -3, and I would just say 5 times 11 is 55. Again, you could put it in your calculator, that works too. All right, number 4. Use the zero exponent rule. Simplify each expression using the zero exponent rule of exponents. Okay. So again, we're going to bring the c cubed up here, and that means we're subtracting 3 from both. So c to the 3 minus 3 is c to the 0 over c to the 0. See, anything to the 0 is 1. I don't care if it's a variable or a constant. So this answer is just 1. -3 x to the 5th over x to the 5th. We're subtracting 5 on both of these. So we get -3 x to the 0 over x to the 0, which becomes -3 times 1 over 1, which is -3. J squared k to the 4th over j squared k times j squared k cubed. Oh, this is gonna be fun. So we're gonna exponent to an exponent. So that's j to the 8th because we multiply them. This k has an exponent of 1, so that becomes k to the 4th because we're multiplying our exponents, over j squared k, nothing's changed there, times j squared k cubed, which is j6 k3. Whew. Now let's multiply our denominators. I'm going to leave our numerator alone. This is kind of fun. J squared times j6, that means we add our exponents, that's j8. K to the 1 times k cubed is k4. We add our exponents when we're multiplying. Now we're going to subtract 8 to bring this up here and subtract 4 to bring it up here. We get j to the 0, k to the 0 over j to the 0, k to the 0. Looks like a bunch of ones happening. All right, fun. All right, so 5rs squared squared over rs squared squared. So that's 5r squared f to the 4th, multiplying our exponents, and then we've got r squared again, s to the 4th. Now you can see you can reduce these to the exact same thing, but because we're dealing with the zero exponent rule, we want to subtract the 2 and subtract the 4. So we get 5, r to the 0, f to the 0, r to the 0, f to the 0. So that just gives us 5. Using the negative exponent rule, write each of the following quotients with a single base. Write answers with positive exponents. This is what I was referring to. So in this case, we've been taking all of our exponents to the numerator. Here, our exponent is positive and larger in the denominator. So we're going to bring the a cubed south to the denominator. So I'm going to subtract 3 from both, and I get, well, a to the 0 over a to the 7th. The a to the 0 doesn't disappear. It's in the numerator now. So it's important. It is 1 over a to the 7th. Positive exponent, golden. Next one, we've got z squared times z, which is z cubed, over z to the 4th. Pardon me. I'm getting hiccups. Subtracting 3 from both, since 4 is larger and positive in the denominator. That gives us the 1 in the numerator, a to the 0, pardon me, over z. This isn't fun. Okay, -5t cubed to the 4th over -5t cubed to the 8th. So I'm going to take that -5 to the 4th. And then I've got t to the 12th, 3 times 4, over -5 to the 8th. And then t to the 24th. Okay, I want to bring the -5 to the 4th to the denominator and subtract 4 from both. So I'm going to subtract 4 from these. And that gives me, and I'm going to subtract 12 from here. And move it to the denominator as well, since the 24 is positive and larger. That's going to give us 1 in the numerator, sorry. And then 8 minus 4 is 4, so -5 to the 4th times t to the 12th. All right, so this would be -5 times -5 is 25. 25 times 25 is 625. So that's 1 over 625 t12. That's how I would answer that. Using the product and quotient rules, All right, we're just gonna go through and do everything. B squared times b to the -8, bases are the same, add the exponents. So that's b to the 2 minus 8, which is b to the -6. We do not want a negative exponent, so this is over 1. So we're gonna add 6 here, and we're going to go down here and go b plus 6. So that's 1 over b to the 6th. Positive exponents. Negative x to the 5th is negative x to the 5th. Anytime you have a negative in the parentheses with an odd exponent, the negative stays. If you have a parenthesis with an even exponent, and there's a negative in here, it becomes positive. A negative times a negative is a positive, times a negative is a negative, times a negative is a positive, times a negative is a negative. So anytime you deal with an odd exponent and there's a negative in the parentheses, it's going to be negative. I want to make sure you knew why I knew that, as far as just went and did it. So now we have negative x. Oh, we need to move this. We can't have a negative exponent. It's got to go south. So times, I'm going to add 5 to both the numerator and the denominator. So this becomes 1. Anything to the 0 power is 1 over x to the 5th. This becomes negative x to the 5th over x to the 5th. And they're both positive, so I'm just going to bring it to the top. And that's negative x to the 0, which is negative 1. All right, last one on this one, negative 7z over negative 7z to the 5th. All right, so that's negative 7z to the 1 over negative 7z to the 5th. I want to bring that numerator 1 to the denominator, so I'm going to subtract 1 from both. This becomes 1 over negative 7z to the 4th. I do not want to calculate negative 7 to the 4th. 49 times 49. Nope, use your calculator. And then we get z to the 4th. Our exponents are positive, we are golden. All right. Maybe I should invest in another calculator, because you can never have enough, right? Using the power of a product rule, ab squared cubed. So we've got a cubed, b to the 6th, 2t to the 15th. So that's 2 to the 15th, t to the 15th. You calculate that 2 to the 15th out. I really don't feel like it because it's a lot. Next one is negative 2w cubed. So we take the negative 2, cube it. We take the w cubed and cube that. Negative 2 cubed is, it's going to be a negative because it's an odd exponent. 2 cubed is 8. And then w to the 9th. 9. All right, 1 over negative z to the 4th. Our exponent's already positive, so that's golden. I'm not going to change anything regarding that. So that's going to be 1 over. It's not going to be negative because it's a positive exponent. So it's going to be a positive 7 at this point. Do I want to change that though? Let's just calculate it. 7 times 7 is 49 times 49. 81, 36. For I think, and then 441. 1584. All right, so that's going to give us a positive 4,851. This is why I didn't want to calculate that. Oh, down here, wrong place. 4,851 z to the 4th. If my calculation is wrong, I'm sorry, but make sure you put negative c to the 4th, 7 to the 4th, and that's what you should get for here, and it should be positive. The next one is e to the negative 2, f to the 7th, all of that to the 7th. First thing I'm going to do is my exponent of 7, so that becomes e to the negative 14, f to the 14. I'm going to add 14 to both sides, to both the numerator and the exponents for the e. So I get 1 over e to the 14th times f to the 14th is f to the 14th over e to the 14th. Again, positive exponents. Using the power of a quotient rule, 4 cubed, 16 times 4, 64, is 4 cubed over z to the 33. Positive exponents, we are good. P to the 6th, Q to the 18th. Exponents are positive, we're good. -1 to the 27th, it's going to be negative because it's an odd. So -1 times -1 times forever and ever, it's going to be -1 over T to the, so 2 times 27 is what? 2 times 7 is 14, 54. Looks right. So -1 over T to the 54. J cubed, K to the -2, all that raised to the 4th. So 3 times 4 is 12. -2 times 4 is -8. So we're going to add 8 to the numerator and the denominator. And we get J to the 12th over K to the 8th. This becomes 0, K to the 0 is 1. Last one here, M to the -2, N to the -2, all that raised to cubed. So that becomes M to the -6, N to the -6. And we do not want negative exponents, so we're going to add 6 to the bottom and the numerator and the denominator. So this becomes M to the 6, N to the 6. That's 1 over M to the 6, N to the 6. Last page. Simplifying exponential expressions. All right. 6m squared into the -1, all of that cubed. So we've got 6 cubed. We've got m to the 6, because 2 times 3. And then we've got n to the -3, -1 times 3. We do not want a negative exponent, so we need to add n cubed to both. 6 cubed is what, 36 times 6? I'll just do it over here. 36, 18, 19, 20, 21. So 216 m to the 6 over n cubed. 17 to the 5th times 17 to the -4 times 17 to the negative cubed. Because these have the same bases, we can just add our exponents. So that's 17 to the 5 minus 4 minus 3. 5 minus 4 is 1. 1 minus 3 is -2. So 17 to the -2. We want to add 2 to both. That gives us 1 over 17 squared. 39? No, it's been a long time. 4, 7, 8, 9, 10, 11. So 119, 9, 10, 3. That can't be right. That's too much. Hold on now. 17 squared. I can do this. 9, 4, 7, 8, 9, 10, 11. Oh, that's what my problem was. It is 289. Cool. All right. U to the -1, V over V to the -1 squared. I'm just going to go through and go U to the -2, just multiplying V to the 2, and then V to the -2. Do not forget to distribute that 2 to the denominator as well. That 2, that square is happening to every term in there. So we've got U, V, and V. The U needs to be positive, so it's got to go south to the denominator. So that's for sure. Let's just go see what we can do here. So +2 and U squared is going to give us a U squared here. The U's gone. Now we've got V. I've got a positive and a negative, so we want to bring it up to the positive. So we get V to the 4th. So our final answer is V to the 4th over U squared. -2 a cubed b to the -1 times 5a to the -2b squared. We are just multiplying. So when you multiply, you add your exponents when they have the same base. So that's -2 times 5 is -10. A cubed times a to the -2 is a to the 3 minus 2. B to the -1 times b squared. Okay, now we can do these. -10 times a, and then b. -1 plus 2 is 1. That's easy enough. X squared square root of 2 to the 4th times x squared square root of 2 to the -4th. Okay, looks like a 1. I'm not going to, well, these are the same bases. So they have the same bases. We can add their exponents, right? So that's x squared square root of 2 all that raised to the 4 minus 4, which is 0. So that's just the whole thing is 1. Because anything to the 0 power is 1. So all that stuff is just 1. The other way to look at this is you've got x squared squared root of 2 to the 4th. And then if you took the negative 4 and put it to the denominator, it would be positive as well. And this would just give you a 1. They would reduce to give you 1. It's the same concept. So however you see it, the main thing is that you understand what you can and cannot do with your exponents. All right, so 3w squared, all that to the 5th, 6w to the negative 2 squared. So 3 to the 5th, w to the 10th, because that's 2 times 5, 6 squared, and then w to the negative 4. All right, so we can do some reducing here too here in a minute. The w to the 10th positive here, so I'm going to add 4 to both, and I get 3 to the 5th, w to the 14th over 6 squared. So what does that look like? Calculation wise, 3 times 3 is 9, so we've got 81 times 3. So 243, w to the 14th over 36. This does reduce. Does it reduce by 6? 6 into 2, so this 6 into 243 would be 4. Nope, but it will reduce by 3. 3 goes into 24 8 times, and 3 goes into 3 once. So this becomes 81 w to the 4th over, and then 3 goes into 36, 8. 2 would be 18, so 3, that would be 12. Oh, this isn't done. There's still another 3 in there. 3 into 81 is 27. 3 into 12 would be 4. So 27 w to the 4th over 4. You've got to reduce it as far as you can go. I don't know why I didn't see that 9 earlier. 9. Mistakes happen. All right. That's when you learn. All right, y'all have a great day. Let me know if you have any questions. Please make sure and share any questions you have during class, office hours, shoot me an email, whatever you need to get a good handle on this. Have a great day, and I'll see you in class.